Pre-statistics, perimeter, value, mixture, and break-even problems involving systems. Lesson objectives: state the four-step problem-solving method. Use a system of two linear equations or a linear function to solve perimeter, value, mixture problems, and break-even problems. Lesson objective: let's review the four steps to solve word problems involving two variables. First step is to understand the problem. Next, we devise a plan. Step 3, carry out the plan. Step 4, look back. So for step 1, understand the problem, here's where we want to assign the variables. So our first step is to understand the problem. What are we trying to solve for? What is the question asking? In this step, we will assign the variables. A lot of times, the variables will be the questions asked in the problem. If there are two variables to solve for, we will need two equations. Step 2, devise a plan. Here's where we will translate the information into equations. We may draw a diagram or a chart. We look for words that translate to operations or variables and form these into equations. And normally this is the hardest part of the problem. Step 3, carry out the plan. We solve the equations. We can use graphing, we can use substitution, or we can use elimination. Most of the time the layout of the equations will determine which is the easiest way to solve the system. Step number 4, looking back, and here's where we check our answer and we interpret what the answer means. So when we solve it, we want to make sure the answer is reasonable. We want to verify it by checking. And we always want to make sure the answer is in terms of the problem. Lesson objective: formula. Recall that the formula of perimeter, the distance around a rectangle with length L and width W, is P equals 2L plus 2W. Example 1. Throughout history, rectangles is about 1.62 times their width are called golden rectangles and have been viewed as the most pleasing to the eye. Many famous structures, including Parthenon in Athens and Great Pyramid of Giza in Cairo, incorporate golden rectangles into their design. So here's an example of a golden rectangle. In this case, the length is about 1.62 times the width. And this 1.62 is known as the golden ratio. Here's a visual of a golden rectangle involving the Greek architecture, Parthenon. If you look at the Great Pyramid of Giza, the length of the pyramid is about 1.62 times the height of the pyramid. In art, the Mona Lisa, as you see here, has been laid out using a golden rectangle. So for example 1, suppose an artist wants a piece of canvas in the shape of a golden rectangle with perimeter of 9 feet. Find the dimensions of the canvas. So the first thing I would do is draw a picture. This is our length and this is our width. These are our two variables. This is what we're trying to find. So W will be the width measured in feet and L will be the length measured in feet. Step 2, we want to write a systems of two equations involving L and W. Now since we know that the length must be 1.62 times the width, we have our first equation. L equals 1.62 times W. The next equation is going to involve perimeter. Since the perimeter needs to be 9 feet, we take our perimeter formula and we substitute 9 in for P, and we have our second equation. 2L plus 2W equals 9. So step 3, we're going to solve this system. The easiest way to solve this system is by substitution, since we have L is equal to 1.62 times W. So we solve the system. Wherever we see an L, we substitute 1.62 W. Now we have an equation only has W's. We can solve for one variable using one equation. So 2 times 1.62 W becomes 3.24 W. Now we combine like terms and we get 5.24 W equals 9. Then we divide, and if we round off to 2 decimal places, we see that W is approximately 1.72. To find L, we go to the first equation, we substitute 1.72 for W, and we get L is approximately equal to 2.78. So the width is about 1.72 feet, and the length is 2.78 feet. Step 4 to check it. If we take 2 times our W plus 2 times our L, we get 9. So that works. If we take our width, 1.72 times 1.62, the golden ratio, we get the length 2.78 rounded off. So it checks. Total value formula. If n objects have a value of v, then their total value t is given by t equals v times n. So in words, the total value is equal to the value of one of the objects times the number of objects. We will use this formula in the next example. Example 2. A music store charges $5 for a 6-string pack of electric guitar strings and $20 for a 4-string pack of electric bass strings. If the store sells 35 packs of strings for a total revenue of $295, how many packs of each type of string were sold? So our first step is to assign the variables. The question is asking how many packs of each type of string were sold. So we want to know what's the number of electric guitar strings sold and the number of bass guitar strings sold. So we'll let X be the number of guitar strings and Y will be the number of bass strings sold. The next step, we want to write a system of 2 equations, and here is where we will use the total value formula. So we know that the revenue from the guitar strings is $5 per pack. So the total will be how much each one costs times the number, which is X. The bass strings sold for $20, so the total will be 20 times the number of bass strings, which is Y, so the revenue will be 20Y. Adding both these will give us our total revenue T. So our first equation is T, total revenue, is equal to 5X plus 20Y. Now from the problem we know the total revenue was $295, so we substitute that for T, and we have our first equation. 295 equals 5X plus 20Y. So we have an equation involving the cost. Our next equation is going to be the number of packs sold. In the problem it is stated that the store sells 35 packs of strings. So we know that the next equation must be X plus Y equals 35. We take the number of guitar strings plus the number of bass strings, that will equal 35. So we have our system. In this case, since the X's line up, the Y's line up, the equal signs line up, and the constants line up, we should solve this by elimination. And probably the easiest way to do that is to take the second equation, equation 2, and multiply it by -5. Or we could multiply it by -20. I'm going to cancel out the x's. So to solve the system, I'm going to take the second equation, multiply it by -5. So we have -5x minus 5y equals -175. I'm going to add that to the first equation, then solve for y. So we have 15y equals 120. We divide by 15 and we see that y is equal to 8. To get x, we take 8 and substitute it into one of the equations. I'm going to use the second equation. So we have x plus 8 equals 35, which means x is 27. So 27 guitar strings were sold and 8 bass strings were sold. Our last step is to check it. So if we take 27 plus 8, we get 35. So that's the number of sets of strings sold. And if we take 5 times 27, the cost of the guitar strings times the number of guitar strings plus the cost of the bass strings times the number of bass strings, add those two up, we get $295. So it checks. Thanks for watching.